Traffic engineers have determined that the mean speed on a rural interstate highway is normally distributed with a mean of 75 miles per hour and a standard deviation of 6 miles per hour. What are the slowest and fastest speeds traveled by the middle 95% of the motorists? Okay. So if you're in the middle 95%, that would put 0.9500 here in the middle. Well, if you have 95% in the middle, that means you have 5% not in the middle. And what would not in the middle be? Well, it would either be in this upper tail or in this lower tail. So that's where the other 5% is. Because of the symmetry of the normal curve, 2.5% of that will be in the upper tail and the other 2.5% will be in the lower tail. If you add these three areas up, 0.0250 plus 0.9500 plus 0.0250, they do add up to 1, which is what we know all the area under the curve must add up to. So here again we're given the probabilities and we want to find the z-scores, and we have two of them to find here. The bottom one corresponds to the slowest speed, the positive z-score corresponds to the fastest speed. Okay, so let's start with the slowest speed. Let's find this z-score right here. We know that to the left we have 0.0250. So we look at the page, the first page of our normal table, the one that has the negative z's, and we look for 0.0250. We will see 0.0250 in the negative 1.9 row and the 0.06 column. So the z-score corresponding to this probability of 0.0250 is negative 1.96. Now, the positive z-score, because of the symmetry of the normal curve, has to be positive 1.96. But if you didn't realize that, you could have figured it out by noting that to the left of the z-score, how much area is there? Well, there's 0.9500 plus 0.0250. So to the left of this upper z-score, there's a total of 0.9750. And had you looked that number up on the second page of your table, 0.9750 is right there, and you see it's in the 1.9 row below the 0.06 column. So our z values here are negative 1.96 and 1.96, but since they gave us the probability, we have to find the z-scores, but really here the x values, because it wants the speed. It's the speed that's normally distributed. So x is equal to mu plus z times sigma, and we're going to have to use this formula twice. Let's get the slowest speed first. So we plug in 75 for mu, negative 1.96 for z, and 6 for sigma. Doing the multiplication on our calculator first and then adding the 75 gives us 63.24, or to the nearest whole number, 63 miles per hour is the slowest speed. Using the formula now to find the biggest speed, the mean is 75. We now take the upper z-score of positive 1.96, sigma is still 0. Do the multiplication first, then add 75. I get 86.76, or to the nearest whole number, the fastest speed traveled by the middle 95% of the motorists is 87 miles per hour.